What's up, everybody? Welcome to my new video. Today we have an exercise. We're going to be removing an anchor from a URL. So what we're going to do here is when we see the hashtag right here, we're going to remove everything after it. And that's pretty much easy. Unless there's like other off buts or whats, you know, sometimes they give you like little exceptions that you got to do. But, you know, if it's what I think it is, then we can just do something like this here. What's going on? Okay. So we just start off with a simple function. We can name it remove URL, and then we'll have a string. Actually, we'll just name it URL, and then down here we'll say we'll go ahead and split it. So we can do actually we can do return URL split. We're gonna split at that, you know, at that. And then we'll return 0 like that. I know I have that space in the middle. Like that. Alright, let's go ahead and go down here. Alright, let's do remove URL. I'm gonna do 2 of them, so I'm gonna go ahead and do this one here. I'm gonna grab this over here. I'm gonna make sure that both of them work. Then I'm gonna grab this one here as well. Make sure that it works, even if I don't have a, you know. Oh, you know what? I can do it with regex too, if anything comes up. So it's loops.js. Alright, that looks pretty good. That looks pretty good. Let's go ahead and insert it. You know, it might be a different name, so let me go ahead and check that first. So the name is URL anchor. Oh, I was close. URL anchor. Alright, and now let's go ahead and copy it. Okay. Let's see. Let's go ahead and test it first. Alright, passes one test. Let's see if it passes the next one. 101. Damn. Okay, it works. That was easy. That was nice. Alright, so we did that. Let's go ahead and... what else should we do? Let's go ahead and open up some more. Let's open up some more that I can do, that I feel like I can do. Some of them are difficult, like this one I tried it already, but that one's a little bit more time consuming. I tried it for like a few hours and it just wasn't working. This one as well. Factorial. You know what, the factorial? It might be easy. I thought I did that one already. Hold on, let me reload it. Sometimes if you don't reload, it doesn't delete the ones you've done already. I have it right here too, where only show me the ones that I haven't completed. So we have sum of odd numbers, the highest profit, sort array by string length. I'll take a look at it and we'll see. Find the capitals. You know, that one might be able to be done with regex. Is it small enough? Yeah, I don't know. Summing of numbers digits. Yeah, we can do that with split and then loop through the... I have to look at the details though. 2 oldest ages. We can sort that and grab the... Grab tool. Yeah, it looks pretty good so far. I'm not gonna do that one right now though. I'm gonna go ahead and do... I'm gonna show you guys what I'm rigging on right now. What I'm working on right now. Alright, so right now I'm working on random variables. This is for... Oh, this is like, yeah, like probabilities and stuff like that. So let's go ahead and read out one page. So, you're no worse off than before. Your chance of winning is still 50%. What is this regarding to though? Let's look at it real quick. Oh, so this is like a game right here. So this is a numbers game. So, let's play a game. I have 2 envelopes. Only 2 envelopes. Each contains an integer in the range of 0 to 100. I did not see that before. I was looking at that earlier. I thought it was 100 envelopes. Okay, so it's only 2. And the numbers are distinct. To win the game, you must determine which envelope contains the larger number. To give you a fighting chance, I'll let you peek at the number in one envelope selected at random. So you can peek, but you can't. You don't have to choose. So if you peek, that changes everything then. No, I'm just kidding. It's talking like I was in a movie or something. That changes everything then. Okay, so in that case, so you have an envelope. If it's above 50, then your chances are above 50%, right? Because it's above. You want to get the highest numbers. I don't know. It might be. It might be not. It might be a good strategy. It might be not. That's what I would do. I don't know. Where was I though? You're no worse off than before. Your chance of winning is still 50%. Combining these 2 cases, your overall chance of winning is better than 50%. Informal arguments about probability like this one often sound plausible, but do not hold up until under close scrutiny. In contrast, this argument sounds completely implausible, but is actually correct. This argument, what's the argument here? There's a strategy that wins 50% regardless of what numbers I put in the envelopes. Suppose you somehow knew the numbers. See, I had read this already, but I kind of read it mindlessly. So, yeah, that's why I'm rereading it. So, between my lower number and higher numbers, now you peek in the envelope and see one or the other. If it is bigger than X, then you know you're picking the high number. If it's bigger than X, but you don't know what X is. If it's smaller than X, then you're peeking at the lower number. In other words, if you know a number X between my lower and higher numbers, then you are certain to win the game. The only flaw with this brilliant strategy is that you do not know X yet. But what if you try to guess X? There is some probability that you guess correctly in case you win 100% of the time. On the other hand, if you guess incorrectly, then you're no worse off. Oh, that's okay. So it hadn't finished with the strategy. Yeah, I mean that one strategy, like if it's 0 to 100, 50% is like under 50, and then 51 and higher for 100. 51 and any number of 51 or higher. No, that's the other percent. So Yeah, I mean, if you can peek at it, and if the number's like 76, uh, yeah, I mean, I guess that's a pretty good chance that that's the higher number. It might be it. Or, I don't know. Let's see. For generality, suppose that I can choose numbers from set 0, 1 through n. Call the lower number L and the higher number H. Your goal is to guess a number X between L and H. Well, it looks like they're going to make a formula for it. For any number, not just 0 through 100. To avoid confusing equality cases, you select X at random from among the half of integers, the half dash integers. Let's see. So we have 1 dash half. We have 1.5, 2.5, up to n minus half. So it's all by halves. But what probability distribution should you choose? The uniform distribution turns out to be your best bet. Uniform distribution, I don't know what that is. An informal justification is that if I figured out that you were unlikely to pick some number, say 50.5, I don't think you can choose that number, I'd always put 50 and 51 in the envelopes. Then you'd be unlikely to pick X. So X between L and H, you would have less chance of winning. So the more in the middle, the less chance of winning. Is that what it's saying? So I'd always put 50 and 51 in the envelopes. After you selected the number X, you peek into an envelope and see some number P. If P is greater than X, then you guess that you're looking at the larger number. Then you guess that the other number is larger. Yeah, this one's a bit confusing, but you know, we move. I'll end it right here. Well, I only have a little bit to read, so we'll just go ahead and finish. All that remains is to determine the probability that this strategy succeeds. We can do this with the usual 4-step method and a tree diagram. Step 1, find the sample space. Okay, we're still working with variables, not the 0 to 100. You either choose X too low or too high, H. Just right is in between X and H. Then you either peek at the lower number or the higher number. Okay, so we have too low, too high, just right. So the correct number is oh, that's what I was talking about over here. So the envelope is, so it has to be, let's see, too high, too low. I'm not sure. PL, you peek the L, peek the H, you lose. Damn. Choice of X, too low. Probability. Oh, I see. Wait, no, I don't. Yeah, it doesn't make sense, but you know, I'm gonna have to stare at it for a little bit longer. Thank you guys for watching. Y'all have a good ass day. Peace out.